Hello and welcome guys. This is the second part of our series on behavior trees where we will start building a simple behavior tree in C++. In the previous video, which was part 1 of this series, we understood what a behavior tree is. We started from the idea of a finite state machine, and then we discovered some problems with finite state machine, and then we moved to behavior trees and saw how behavior trees solve those problems. Now, this video is all about us actually implementing behavior trees in C++ because of course, we haven't understood it well unless we can actually build something, right? So the library I'm using to build behavior trees in C++ is called BehaviorTree.CPP. This is actually made and maintained by Davide. Shout out to Davide for this amazing library. I'm adding a link in the description of this video, which is to this library, and you can refer the documentation or the open source project, which is on GitHub, to understand more about this. In fact, I've also read the official documentation and the GitHub repo to make these videos right now. To make a behavior tree using this library BehaviorTree.CPP, we actually will have 3 different components in our project directory. One will be our code file, which will be a CPP file. That will have all the code for us to execute the behavior tree. The second one will be an XML file, which will actually have the entire design of a behavior tree. So when you have that XML file, it will be parsed in your code to understand what the behavior tree looks like. Your CPP file will have all the functionality of your execution nodes, and your XML file will have the entire design, which will include how the control flow is. So all information about your control flow node, if you have sequence nodes, if you have fallback nodes, or whichever control flow nodes you have, along with how your leaf nodes or your execution nodes are connected. So basically the entire design. And the third one is just your CMake lists file, which defines how the project has to be built, right? So the first two are specific to behavior tree and how it is made. The last one is just how you build a C++ project, right? So let's start. Now, because I love working with examples to build something all the time, this is the example behavior tree we will build in this part of the video. And in the next part of the series, we will actually build a little more complicated behavior tree. So this simple behavior tree is just for a pick and place manipulator. We first check the battery to see if it has enough power. Then we open the gripper, we approach the object to be picked, and then we close the gripper. We won't go to dropping the object in this video because this is supposed to be a very simple demonstration of making a behavior tree in C++ using the library. So looking at this behavior tree, the root node is actually a sequence and it has 4 children. The first one is check battery, which is a condition node, and the other 3, open gripper, approach object, and close gripper, these 3 are action nodes. That's all we want to do. We want to make a simple behavior tree. So let's get started. The first thing we have to do is we have to get the library, which is BehaviorTree.CPP. I've added the link in the description. As I said before, you can check that out, but let's talk about the steps and do it step by step. Here is a dummy directory, which is BT demo or behavior tree demo. The first thing I'll do is clone the open source project, which is on GitHub. I've added the link in the description, and that is the one I'm using right now. So this is where I'm cloning the library. The library is cloned. Now let's go to the library. One other thing you have to do before using this library or even installing this library is you have to install dependencies, and these are the dependencies. So you have all the dependencies. I actually have all the dependencies already, so I don't need any more installation, but this is a required step. We need to compile and install this library before we can use it. So let's do that. Let's make a build directory. Let's use the CMake lists file here. Now let's make the file. Okay, perfect. We have compiled the library. Now we need to install the library on our system. So for that, sudo make install. Your library is actually installed. So now you can use BehaviorTree.CPP in your C++ code easily to build a behavior tree. Let's do that now. You can go to whichever directory you want. I am going back to BT demo to make a new project now. Let's make a new directory where we will have our simple behavior tree project. This is where we can start coding now, right? So let's open Visual Studio Code. So this is my Visual Studio Code in the directory. You can use whichever editor you want or whichever IDE you want. I use Visual Studio Code because I love it. Let's now make a new file, which will basically host all the code. This is our boilerplate code for int main. Now remember the behavior tree we want to make, and this is how we start making it. Just some imports we'll need. We need IOStream for standard stuff. We need chrono because we will be adding some delay to the thread. So that is where chrono comes in. We also need to add behavior tree libraries, and let's see what we can do here. We will be using this include for action node because we have to create action nodes for this behavior tree, right? So that is where that comes into picture. We need to use BT factory because that is one of the interfaces we have to use to actually create a behavior tree. We will come to that in a bit. So if this doesn't make sense right now, don't worry about it. Chrono literals because we have to use this to add delays, and we'll use this later. Now looking at the behavior tree we want to create, each leaf node is actually a functionality, right? Or you can say these leaf nodes are actually different tasks. The nodes which are actually not leaf nodes are just all about moving the control from one point to the other. So the flow of control is managed by these non-leaf nodes. So looking at these leaf nodes, for each of them, we need to actually have a functionality or a task. How can we do that? We can actually look at each leaf node as a function, right? So let's say you have a function for battery check that can correspond to a leaf node. You have a leaf node for opening the gripper, right? Open gripper. So that will actually correspond to a function. Same with approach object, same with close object. So what's actually happening is each leaf node has to correspond to a function or a method so that we can encapsulate the functionality of that leaf node or represent the functionality of that leaf node in code in a function or a method. So that is all we want to do. So there are different ways to do it. And in this example, I've referred behavior tree official documentation to add all these different ways. So one of the ways is to actually make a class which represents the node itself. So for that, we actually have to make a class which inherits from an action node class. An action node class is already present in the library. We can use that. So the first and actually officially preferred way is to make a class which is of the type node and which has a method which represents this task or functionality for the leaf node. So this is the first way. Talking about the second way, let's say you already have a function, but you need to register that function as a leaf node or a task. So that is the second way. The third way is, let's say in your system, you already have a class with methods, but this class doesn't inherit from node. This is your own custom class. So you can still register the method inside that class as a method which can be used when the leaf node is actually executed. So as a task. So the third one is basically custom class method. Let's build all of them one by one. Looking at the first one, let's use the leaf node approach object and make a class which inherits from some kind of node class from the library. And then you will have a method which represents the actual functionality of the leaf node. So this is our boilerplate class for approach object leaf node. This will have a method which will be registered as the functionality or the task for this leaf node. So whenever the leaf node will be ticked, the method we are talking about will be called, and that is how the functionality is executed. If you also look at what this class is inheriting from, this is basically from the namespace behavior tree from our library and sync action node. Action node is basically an action node as we've discussed before. Sync actually means that this will be a synchronous task when the functionality or the method will be actually ticked. That means this will be a blocking call. So whenever the leaf node is ticked, which means the corresponding functionality in this class will be used, it will be a blocking call. So other nodes in this behavior tree won't be able to respond unless this node has done its job. Let's have a constructor here. So this is your constructor. It takes in the name, and then that name is basically the name of the node. So you have to pass it to the parent class. We don't want to do anything in the constructor right now. This class is all about making the method, which is the actual functionality when the leaf node is ticked or when approach object is ticked. The method we've been talking about, which will be executed when this node is ticked, is called tick. So it's of course easy to remember. And this method is actually already there in the parent class. You need to override this method, and you necessarily need to override this method. So let's make that method. This is your boilerplate method. This method returns node status, which is of course a part of the library again. This node status can be failure, success, running. In our case, we will not have running because we have synchronous nodes. Synchronous nodes do not return running. So if you've read the documentation already, synchronous nodes do not return running. They return either success or failures because these are blocking ones. Now, because this is a simple node, what we'll do here is whenever approach object leaf is ticked, we will just print that approach object is ticked. And then we will sleep for a while, which basically represents a pseudo functionality, right? We can basically sleep for, let's say, 5 seconds. And after that, we can return a success, which signifies that this task was successfully done or approach object was successfully done and completed. So this is where we print. We are printing the name of the node as well. And after that, we sleep for 5 seconds and then we return success. Okay, so this is where we are. Now we see 5 seconds here, right? That is why I used namespace std chrono literals so that we can just write 5 seconds here. So this was the first way of using the node class to make a leaf node. Now let's go to the second method. Let's say you have a function in your code base and you want to register that as the functionality for your specific leaf node. That can also be done. Let's say we have a function to check battery, and that is what we will implement here. So in that case, the return value still needs to be node status. This is the boilerplate function you want to register for check battery leaf node. Let's just do the same. If this node is ticked, so this function is executed and we just print something and then we return success. Let's not add any delay here because this is not an action node. This is a condition node. So this will just check for something and then return immediately. Let's just print battery okay and return success here then. Okay, so this was the second way of making a leaf node using just a function and no methods and no node classes. The last one is basically about you already having a custom class and you want to register their methods as the functionalities for each leaf node execution, which basically means custom class methods, right? So let's do that now. We have 2 more leaf nodes or basically functionalities remaining for this behavior tree. Let's have a class called gripper interface, which will have both the methods for opening and closing, and then we'll register each method separately as a leaf node in the behavior tree later. So let's do that. Okay, so this is our class. The one thing we want to do is make a constructor. So this is our constructor. What we need to do now is make 2 methods, one for opening and the other one for closing. So this is the first method for opening and this is the second method for closing. So we have one method open for opening the gripper and the second one which is close for closing the gripper. If the corresponding leaf node is ticked, we print something and then return success. We can of course add a delay. So if you want, you can add a delay. Otherwise you can choose to not add a delay. I will not add a delay here because this is dummy functionality and adding or not adding a delay does not change much for our use case, right? So that's still fine. For open, let's print gripper open and then return success. For close, let's just do the same where we print gripper close and then return success. Now for usually something like gripper interface, you would also want to store the status of the gripper, right? So that is trivial for this example and you can do that. Let's just do that. Let's make a private variable which will be the state of the gripper. Okay, so you have a private variable which will be a boolean. If it's open, then underscore open will be true, otherwise it will be false. We can also initialize this in our initializer list when we are actually making the object. So let's also do that. So on line 35, we initialized underscore open to true. So when the object of this class is created, it is defaulted to true. And then let's use these methods to change the state. If the method open is called, which means the leaf node for opening the gripper is ticked, then open is set to true. For close, it is basically set to false. Okay, so here we effectively have all the functionality for our 4 leaf nodes. The first one is for checking the battery, the second one is for opening the gripper, the third one is for approaching the object, and the fourth one is for closing the gripper. Now this basically means that if we have a method or a function, we can actually treat it as a leaf node, right? That is the idea behind that, so that whatever code you have, as long as you have methods or functions corresponding to your leaf functionalities in your behavior tree, you can register them as leaf nodes. But the question is, how do we do that? How do we use the behavior tree? Because we still haven't done that. That is what will happen right now. Let's go to our main function where we will do all of this. We have something called behavior tree factory, which is basically the place where you register your entire behavior tree and that will store your behavior tree. So let's use that. So this is your behavior tree factory object, and we will use this to register all different kinds of nodes in your tree. Let's register these methods or functions as node functionalities in the same order as we created them. The first one is for approaching the object. The string name is important because that will also be used in our XML file when we actually describe the design of our behavior tree. Here we use something called register node type, and that is used only when you're actually creating a class which inherits from a node from our library, and otherwise we can use something else. So in our case, what we'll use is register simple condition for the next one. Register simple condition is basically registering the function you have, check battery, using std bind, which is a C++ concept. You can always check out my video on std bind. So register simple condition is a method for you to register a simple condition node, which basically provides an easy to use condition node. So here you can understand that this is how you can register your condition node. Now let's also register the other 2 action nodes, which will be for opening the gripper and closing the gripper. So for that, you also need to create an object of the class gripper interface. Let's also do that. This is your object of the class gripper interface called gripper. So now we can register the two methods inside this instance, which will be basically two different leaf nodes in our behavior tree. This is the first one where you're registering your open gripper leaf node. As I said before, this string name is super important because we have to use the same when we're using our XML file to create the design of our behavior tree. I've used stdbind to get a pointer of our method for the instance gripper. Okay, we see register simple action here, which is a method for you to register simple action nodes, where a simple action node basically represents a synchronous action node, which is also something we used for approach object. So this is basically a way for you to register synchronous action nodes without you having to inherit from a node class, and then you can use your own class and methods for all of this. So this was for open gripper, and there will be a corresponding one for close gripper, right? And which will effectively be the same with different names. Okay, so this was the one for close gripper. So your factory now has all information about different leaf nodes, and that is all you need to give here. After this, we need to basically create our tree. To create our tree in C++, what we do is we use a method called createTreeFromFile, where the file will be your XML file, which decides the design. In your XML file, you will have description about how the flow is in your behavior tree or how your behavior tree looks like. This is how you create your tree using factory and the method createTreeFromFile. This file will be in your location, which is current directory, but you go back by one, and then you have BehaviorTree.XML, which is something we will create. Now we need this path because we will later build this code. So once you have compiled this code, it will be in the directory build, which is also something we'll make. And then you have to come back by one from build and then look at the file. So don't worry about the path right now, because you'll understand why the path is this way once we actually build. Okay, so we've created the tree, but as we've discussed before, the concept of a behavior tree is that you need to start the tick, which is like a nudge to different nodes, right? If you're not sure about this, please check out part 1 of this video where we talk about all the concepts in a behavior tree. Let's say our XML file was already present, which is something we'll do in a bit. In line 76, what we are actually doing is we have our tree ready. Now we need to tick the tree. We can tick the tree again and again. Right now for this demonstration, we will just tick this tree once. So what will happen here is this is our tree. If you tick it once, the root node will propagate this tick to its children. We have 4 different children. All of them are leaf nodes. So in this case, the root node is a sequence node. So it will first tick the left one, then the next one, and the next one, and then the 4th one. We've discussed this idea in the previous video, so I'll skip that. But this is basically where you tick it. Right now for this example, we are just ticking it once. So once this tree is executed, we do not tick it again and again. We have our code ready. Line 79 is where we actually use this behavior tree just to tick it once. But previously we were discussing about BehaviorTree.XML, which is where your design of the behavior tree lies. Because right now what we've done in this code is we have described our execution nodes, but basically to understand the entire behavior tree and how the control flow is, you have to give information about control flow nodes and execution nodes both, right? So that happens in your XML file. And as I said, that is where the design of your entire behavior tree is. So let's create an XML file. bt_tree.xml is our XML file. Let's make the behavior tree design here, which will be parsed by factory to understand how the behavior tree works. So we start at the root of the tree where you say that this is the main tree to execute. And then this is your main tree, which is the behavior tree. This behavior tree on the topmost layer has one node, which is the sequence node, right? So that is what we define here. So the hierarchy is in such a way that below your sequence node, you have 4 leaf nodes: check battery, open gripper, approach object, close gripper. And here the first part of this tag is basically the same as the string you gave in your C++ code, right? So check battery, open gripper, approach object, close gripper. Those were the 4 strings we used to register these 4 nodes. That's why I said that those string names are super important. The name subfield is optional here, but I've still given it here. So this is basically your entire behavior tree design, where you said that, okay, I have one sequence node, and under the sequence node, I have these 4 nodes, which are leaf nodes. If you have the sequence node, you use the word sequence. If you have a fallback node, you use the word fallback, and so on and so forth. We will go into a more complicated behavior tree in the next video, but this video should be super simple. So this is where we have our behavior tree design ready. And then we also have the functionality ready in our C++ code. What do we need? We need to build this project. To build this project, we need to make a CMakeLists file, right? So let's do that. Okay, we have a CMakeLists.txt in the same directory. And now we just need to basically give make commands here. So this is your CMake lists file for this project. The project name is simplebt, that is what I named it right now. And then the file is also simple_bt.cpp. So that is where you add your executable for line 9 and the project name on line 3. Also line 7 says that you need to use this package BehaviorTree_CPP_v3, and that is the one we are using. And line 10 says that this is the library you have to link. So this is our CMake lists file. We actually have the entire project ready for this behavior tree. And let's see what actually happens when we build this project. To build this project, let's go to the terminal and go to this directory. Okay, here is our terminal. Let's go to this directory. It was simplebt. Let's make a build directory for this project. We are in our build directory now. Let's run our CMake using the CMake lists file. Okay, our build is done. We also have our make file, so let's just make it. Okay, there is an error here. Let's see, line 61. Okay, we have an error here, and I think I know what the problem is. So let's just go and fix that. Here in approach object, we forgot to add public, right? Let's build this again now. Right, so now we have our executable ready because everything was built. So you have your executable called simplebt. Let's run simplebt. Battery was okay, gripper open, there was no delay there. Approach object waits for 5 seconds and then gripper closed. So let's run this again. Here we wait for 5 seconds, right? So this behavior tree started from the root node, which was the sequence node, and then the sequence node took the left child, which was battery okay, then battery okay returned success, then gripper open, that was also success, approach object was also successful, the name of the node was approach_object, which is something we gave as an optional argument in our XML file, right? And the last one was gripper close. So basically all the 4 nodes were executed one after the other. Effectively, each node was like a function. And you have to understand that a behavior tree, unlike a finite state machine, is like you send a request and then the control comes back to you. But in a finite state machine, there is no coming back of control. This is something which is also there in the book I referred for the first video. You can also look at BehaviorTree.CPP documentation online, which is official, and I've added the link in the description below. You can understand a lot more from that. And again, that is what I referred in this video. This example actually is an example from BehaviorTree.CPP official documentation itself. So this is basically how you make a behavior tree in C++ using the library BehaviorTree.CPP. One thing for you to remember here is that bt_tree.xml was in this directory, but when we gave the path, it was slightly different, right? The path was current directory going back by 1 and then bt_tree.xml. That was because we execute from build in our example right now. So the build directory has your executable, we execute from there. So we come out of build and then we search for bt_tree.xml. So that is why we use this path. If the executable were in the same directory as bt_tree.xml, we would basically search in the directory itself instead of going back by 1. So this was a simple example of making a behavior tree. Now that we know how a behavior tree can actually be made in C++ using this library, we will now go back to this example we discussed in the previous video. So how about we make a behavior tree for this example in the next video? Let's do that in the next video, and I hopefully will see you there again. Bye bye and have a great day.